Again, I want to thank the speakers of this panel, Anvar, Gusts, and Dovidas. It's really great to see how this project is moving from strategic planning to actual tangible realization. So, the next part of today's program is a very exciting one. So, since the Rail Baltica project was launched, it has set new quality standards in public procurement, health and safety requirements, as well as other domains. And so the Rail Baltica system engineering team aims to introduce international best practice to systematize the working practices and frameworks to ensure a smooth and traceable project implementation, having safety as the primary objective. I now give the floor to my colleagues, Alvaro Rex Sanchez, Head of System Engineering and Assurance Department, and Maria Angeles de la Sierra Aparicio, Deputy Head of System Engineering and Assurance Department.
Hello. Thank you, Linda. Good afternoon. Yes, my name is Alvaro Rex Sanchez, and I am Head of System Engineering and Assurance Department in RB Rail. And together with my colleague, Maria de la Sierra, we are going to introduce briefly the system engineering methodology concept that is defined for the implementation of the Rail Baltica project, and based on which we aim to build the demonstration that the system has achieved its requirements, and particularly, as was mentioned, the safety demonstration. So, this presentation is going to be split in three parts: the why we need it, the what does it contain, this system engineering methodology, and how we plan at a high level to implement this methodology. So, the target, the scope, and the main reason for these processes to be implemented is that we need to implement a single, integrated, safe, reliable, and interoperable railway system, and we need to build the demonstration. We need to collect a standardized evidence that this is achieved. And this, in this particular project, due to the scale and complexity of the context, this is particularly important. We have 3 countries with 3 different administrations, 3 implementing bodies, national safety authorities, but we also have different subsystems with different suppliers that also come at different times, and the whole line, especially on the infrastructure part, is split in different pieces. So there's no way we can demonstrate such a safe and integrated system if we don't put in place a common framework to provide evidence about that. And on top of that, well, we, as also for this demonstration, but also as a legacy, we aim to increase the awareness of the industry and the suppliers in regards to this safety demonstration. So we will have a consistent way to demonstrate the compliance with these requirements. We will additionally comply with legislation, both locally but also coming from EU. And ultimately, we will be able to deliver a unified, coherent system. Particularly important, as I said, is the link with the safety. And this is obviously a mandatory scheme coming from EU directives, particularly the one called the Common Safety Method, that requires a risk management process to be put in place and evidence of application, which is, by the way, assessed and evaluated by an independent certified body, the assessment body, which will produce a report in the end to be handed to the national safety authorities for them to accept the putting in service of the railway line. So this risk management process has to be backed up or supported by different areas, different processes that will help along the life cycle of the project and for all the parts and systems, subsystems, components that form the whole railway system to collect this common evidence. Those processes, which Maria is going to briefly mention now, are requirements and configuration management, interfaces and integration, verification and validation, as well as design and construction management process, for example. So all of them applied together will allow us to build this demonstration for the application of the risk management process and ultimately the placing in service and all the positive certifications for the line. So I give the floor now to you, Maria, to go in more detail. Thank you.
Thank you, Alvaro. And thank you to you, colleagues on the industry. It's a pleasure to be here with you presenting the system engineering processes. As Alvaro mentioned, the structure of the presentation is around three main questions. Now we understand why we need system engineering processes, and in the next steps we will understand what are we putting in place and how we are doing the implementation, how we are tackling the implementation of the system engineering processes. About the what. First, what? What is the scope of applicability of these processes? The system engineering processes, and obviously is the system. And there in front of you, you have the railway system, as in the European legislation described. You see also the infra part, split in mainland and facilities, which is the split that we have in this project. And why do I understress that the infra part? It's because we are also going to implement system engineering process in the infrastructure part, in the infrastructure projects. And the point is that when we think about safety, which is our main goal, we tend to think only CCS, to associate safety to CCS subsystem. But this is not so. As we know from the introduction, we need to prove the proper risk management in the system and safety in the system. And this is why infra is also our target. And now that we are delivering, we are finishing the designs, we are starting constructions, I want to understress that is relevant. I want to raise the concern to manage properly safety already in the infra part. And this is about the scope. Second, what? What are the pillars that we are going to implement inside the interface, the system engineering processes and all these requirements interfaces in order to assure that the processes facilitate the safety demonstration? First pillar, the Senelec life cycle. This shall be the V model, the RAMS life cycle, we all know, shall be the life cycle of the Rail Baltica global project. Second pillar, very important to achieve this coherent approach. This is to have common requirements all over the project. And how do we assure this in our project? First, because we have a single contracting scheme for NE, CCS, and most of the materials contracts. Second, very important, because we have the design guidelines in this project. They are defined and approved by the IBs, the three IBs with RBR together. These are not only a matter of eligibility, all the contractors have to comply with the design guidelines, but they are also a matter of safety demonstration. We need to prove compliance with the design guidelines. Third pillar, towards this safe approach. We have a global RAMS plan for the whole project. This means that we have common safety principles and common risk management methodology approach all over the project. Also, we have a single common operational concept. We have a single system definition with a system architecture reflected in the product breakdown structure. And this architecture, together with common requirements, means that we have a single functional architecture with same scheme for interfaces. And this way, we have kind of a standard specification for all over this project to implement in the whole project. And this, if you think of the V life cycle, this is covering the 5 first stages in the V life cycle. But then we need to understand what are we doing to also cover, to introduce system engineering processes in the rest of the V life cycle. So the rest of the V life cycle, as we all know, are design, construction, manufacture, installation, validation, integration, test and commissioning. So what are we going to do to also implement the system engineering processes there? For design and these phases is when you, contractors, no? You providers in the industry, you will enter in the game, also with us. And as you do what is your expertise to design, to construct, whatever, what we need to put in place is a mechanism to articulate mechanisms with you to be able to collect the data that is later needed for this safety demonstration. What is the data that we need to collect? We need to collect the data about the requirements implementation, which is the status of the requirements. We need to collect the evidence that this status and these works have been done. We also need to collect the history, not only data and evidence, but also the history, how this was done. And not only the sequence. Also, we need to understand and to give clarity what happened in the project. Which were the defects erased? Which were the changes? What was the reason for that? What was the impact? What was the solution, the decision made to solve that, right? All this is part of the requirements process and of the safety demonstration, and supported by the configuration and change management processes. And these are all the things that we need to put in place as process. Then we need support from tools, requirements management tool, asset management tool, and documentation management tools. And this shall be regulated by processes for the specific phases, right? So we will have specific processes for design, for manufacturing, for construction phases. These plans shall be written and agreed, no? Shall be proposed and agreed by contractors and agreed by us, by the project, so that to regulate how every phase is going to run, which is going to be the baseline delivery scheme, which are going to be the products delivered, which are going to be the actors from you that will take place that will work for the project. All this shall be regulated in these system engineering plans. Right? So in the end, what we have is a set of plans which are transversal for the phases, design, construction, manufacturing, integration, test and commissioning processes, right, for the phases, and other supporting processes that take place all over the project, which are requirements management, interfaces management, verification and validation, and configuration management, right? Okay, so this is as what do we have to implement. And now I will go to the how. And thinking of the methodology, let's explain that what is a process itself. A process is not, but the goal is to implement a life cycle, right? And we need to put the methodology to be able to implement that life cycle. So we have organizations. This means actors that are going to do the works. We have activities, specific activities related to what we have to do. We have also a flowchart, because the activities there, we need to see the connection between those activities. What comes next? What is the trigger of the next activity? And we need to understand also and regulate, so to say, to have this common comprehensive framework, we need to understand which actors interact with these activities and how, meaning who is responsible, who is supporting, who is informed only, and this is a RATSI matrix. So we will have activities, organizations, flowcharts, and RATSI matrices, and we will have the tooling environment. And all this constitutes a process. Then, about the methodology we are implementing. With the methodology we put in place, we will have a single organization breakdown structure, which is an abstraction for all the project, right? We have a single life cycle for all the phases, meaning that no matter design, construction, manufacturing, we have the single same scheme, same pattern for the life cycle. And we also have then work breakdown structure. This is the activities. And this is more specific to the different subsystems. But in any case, we see a lot of commonalities in these activities because the aim is to prove safety, right? So, and then another way to remark that this part is for the comprehensive, coherent approach all over the project and for all actors and subsystems, but how we are going supporting safety from the methodology, we are introducing inside this life cycle, inside each phase, we are dividing into sub-phases in which we are introducing revision points. These are gates. These are typical procedural milestones gates process, but this is also this was also assessed by our safety assessors, ASBO, our ASBO, to include that as a means to have control on the proper implementation of the process in a more granular basis, right? So after every sub-phase, the implementation, the preparatory phase, the execution, the compliance, the whatever, so in every phase, we will introduce these checking points to be able to decide, together with the contractor and client, what was done, if this is according to the criteria expected, and to make a decision whether the project can move on or we still need to go back and to improve some parts. By this, what we are doing, we are improving traceability, we are enhancing accessibility, there will be pure clarity, and we will be collecting everything step by step, granularly. And in this way, we will be enhancing also an early detection of problems in the system. Then going a bit deeper in the how, and more deeper because this is about the tool that we are going to use. We mentioned already, we have some pillars that enable already this comprehensive approach all over the project, which is a coherent approach also, which is to have a single system concept. We have a single product breakdown structure. There is another pillar in this project, very important, which is asset orientation. Our methodology is asset-oriented, and this, together with the requirements tool in the project, we are creating a common platform, a single common platform, where we will be able to see assets implemented, and this means that we are not only able to see requirements there, we will be specific objects, specific assets with requirements inside, and we will be the specific requirements implemented in that specific object, and we will be able to associate that to a location, right? So this asset orientation will be also trackable in this platform. In the platform, in this requirements tool, we will integrate to the documentation system as a means to have already integrated their access to all the documentary evidences. In the platform, we will be able to enforce the organization and the activities. Then we will also, this platform shall also be the database for data for defects, and changes, and also the database for hazards and for risk management. And such a platform shall be like the unique source of truth, so to say, for assessors to look later into the evidences, how the project was implemented. And such a comprehensive approach, I dare to say, correct me if I'm wrong, that such a platform with asset-oriented database for defects, changes, hazards, risks, with full traceability, also for integration and validation parts, is quite a unique approach in the industry those days. And then, well, going a bit deeper, but this is just details, how a requirements management tool look like, in case you didn't have access so far to that. Here you can see which is the level of detail of information that we can track in a requirements tool. So if you have the time to see the details, you will see perfectly recorded there the requirements, the sources for that, even the chapters or in the norm or whatever the source is, the text in several languages. You can already see actors and responsibilities defined there. You can see the verification strategy specified and linked specifically to each requirement. You can see also the implementation part where every object in the end is located. So everything that I mentioned, you can see there how this is implemented in reality. And then, just to finish the presentation, going back to the first slide, just like closing the loop, just to mention that these are our targets, these are our great challenges, I would say. This is the benefits we need to obtain. And the value proposition was to implement system engineering processes in order as a means to achieve that. And with this presentation, I think we have a view how really these system engineering processes will be a means to allow us to get these benefits, to overcome these challenges, and to reach these targets. Thank you. This is it.
Thank you.
Thank you, colleagues. So we have quite a few questions that came in during your presentation.
Okay.
First one is a very practical one. What is the meaning of abbreviations OBS and WBS shown on the slides?
What are the meaning of this abbreviation?
Yes.
Organization breakdown structure and work breakdown structure. And they are quite usual terms in system engineering terminology, and in the domain, right? To define the organization that you rely on, and which is the working force, the activities that these organizations shall implement, and also the scope, the responsibility split for that, right?
All right. I will ask a question to the head of these departments, because I like a bit provocative questions. So isn't system engineering duplicating a number of existing supervisory and conformity assessment activities already prescribed by law?
Okay, no. Answer is no. I'll take that one. This is not a duplication because this is not an assessment. What we aim to achieve with this methodology, as said at the beginning, is that we need to compile a consistent and standardized evidence of compliance with these regulations so that the assessment can positively conclude that the system and all its parties, its components, are safe, interoperable, and integrated with each other. So this is not overlapping or duplicating any existing assessment or regulation. This is the way that the project, due to the complexity and the scale that I mentioned at the beginning, is going to achieve this common demonstration. But it's not, again, a duplication.
Thank you.
That was not too bad. You
Very
said
good.
it was a provocative.
It was a clear answer, no, and you elaborated.
Yes.
Very good.
Okay.
So, two questions that are related. One of them, what will be in practical terms the obligations of a supplier in regard to system engineering processes? And we had somewhere also a question, how does it actually work? So I think these are related.
Okay, I can start and then you complement.
You are the head.
In practical terms, as Maria was saying, we are going to have, or we have, a set of documents, a set of processes applying to different areas of the project, where the different responsibilities and accountabilities for every party, not only for suppliers, but also for the project and different entities within the project, need to apply, so that depending on the subsystem, component, material and phase that the supplier is participating in the project, a particular piece of these responsibility matrices will apply, and that will be known and obviously presented, and it's already described in the processes. And based on that, these processes also will highlight or will define which kind of evidence the supplier has to produce in a particular way because the project is also producing the framework for this application of the processes in terms of tools, in terms of templates, in terms of format. So at the beginning of any supplier-contractor relationship with the project, this will be presented, introduced, and well, initial training, if you want, will be done. But then every supplier will need to comply with this by making sure that these evidences are produced according to the processes, and the project obviously will supervise that this is so.
Mm-hmm.
And Maria, I don't know if you want to add something.
No, because I mean, I don't want to repeat myself. This was already explained you perfectly, so okay. I think it's clear.
Another question related to systems engineering is the existence of a require management software tool was mentioned. So how will these suppliers get access to the tool and interact with it?
Mm-hmm. Okay, it's my turn, right? Okay.
Go ahead. That's your
well, let's say that requirements management software tool, requirements management tools can be used to track software, but this will not be our case. We are not going to track the software of the providers. We are going to track only requirements management in that tool, right? And this is for any product, no matter software, hardware, whatever. And about the system of this tool and how will the suppliers access to that, yeah, the point is the platform, this generic platform that I mentioned, this is going to be provided by Rail Baltica Global Project. All actors shall work in that platform, and they can have their own system engineering environments for sure, but in the end, the common platform will be the final place to update all the information for us to have available, right? The access to the platform, of course, there will be actors with determined roles. There will be maybe developers, testers, whatever, acting in these designers, sorry, not developers, designers, verifiers, checkers, acting in this platform. They will have different roles, different permissions, different access rights, and the access of these persons will be through licenses. Then what else? Yeah, you mentioned that there will be a training, of course, because whatever tool we are using, in the end is not about, this will not be a general training of the tool. It will be a training of the tools and the platform in the scope of Rail Baltica Global Project, and according to our specific implementation and configuration. Right, so yeah, and contractors, everyone, contractors, as our contractees, and everyone, assessors, will have access to that platform, as defined in the processes. And yeah, well, then this is it. I think mostly every contractor will have to have a system, a requirements management process, for instance, to specify more exactly which exactly will be that persons interacting, and some other details. So well, these are the means how we will interact through plans, training, and this general platform, actors with different roles being trained and guided by the project management, the delivery organizations, which is us. So this is it.
All right. With the next question, I will take a personal risk. As I'm novel to the field of system engineering, this question might not be related. So
okay.
You tell me. Question, Lars Zimmermann. Do you consider track and tracing technology as a technology to increase your compliance safety management system? Is that something that relates to system engineering, or did I just shoot completely wrong?
Not sure what track and tracing technology means.
What
exactly.
is meant.
Mm-hmm.
So,
but as summarized a bit during the presentation, when we talk about risk management system and the demonstration about that, any, again, component requirement subsystem that needs to comply with some safety requirements will need to provide a methodology and an evidence how these risks
exactly.
are mitigated. And in general, there is not a single way to mitigate risks. And this is what the exercise is always on the side of the project, to demonstrate how the risks are mitigated. So there might be different technologies like this track and tracing methodology to mitigate some risks. If that is the case, and any supplier is applying this methodology for that, of course, it can be part of the risk or safety management process.
Mm-hmm. Exactly. Let's say that we are implementing the system engineering processes as a global platform, global support, but then, for instance, the verification or validation strategies, integration, this is defined by every contractor, and in this verification, validation, integration plans. And there, the proposal of the methodology to use, this shall be proposed by there are methodologies already stated by the project, but there is also already always option to improve or to propose the methodologies, and this shall be done in these system engineering plans, verification, validation, integration plans, to be approved by the Rail Baltica global project. So if this methodology useful for that, this will be matter of discussion, proposal from contractor, and acceptance by our Rail Baltica global project.
All right, thank you. Still some questions. So what are your ideas on model-based system engineering and digital twins for signaling design? Or is that a bit...
Well, this is more matter. Exactly, these are technologies that are used for design, but as we said, we are not. This is the matter of the contractor itself. So we are not working in the provider's point of view. We are not delivering the products. We are not designers of the products. What we need to trace is what is implemented, right? So we have our requirements and your methodologies to design or your techniques. This is up of decision to the providers. What we need to trace is the evidence that our requirements are fulfilled and that evidence, the verification, integration was properly done. So for internal development of the products, we have not a word there. This is the industry, the providers deciding, and as infrastructure managers or supporters of the infrastructure managers, we responsible for this project, we just care for that results and the correct implementation of the requirements. And in the end, the safety demonstration.
Correct.
All right. Well, that's all from my part. Thank you very much for introducing this very important subject.
Thanks a lot.
For your attention. Thank you.
Thank you. Bye.